Hello viewers, welcome once again to my channel. In this video we are going to discuss the normal distribution. If this is your first time of viewing, kindly consider subscribing to my channel. It gives you notification whenever a new video is uploaded. Now, normal distribution is a continuous probability distribution, unlike the Poisson distribution, which is a discrete probability distribution with the binomial distribution. All right, they are discrete in the sense that they test whole number values, while this one, which is continuous probability distribution, take values that might not be whole numbers, just like the height of students in a class, which you can measure like as 7.5, 8.3, etc. Those kind of data are known as continuous data. So, and it is this normal distribution that we use to test them. Now, for a proper understanding of the normal distribution, you need to understand and see how the normal distribution curve looks like. The normal distribution curve is a U-shaped curve, is a parabola where the mean is equivalent to the median. All right, so look at the curve now. So the curve of the normal distribution looks like something like this, which I've made. This is the center here, where you have the mean male. The mean is equivalent to the median. All right. Now, a little deviation from the mean, let's say one step, we give us standard deviation. That's a deviation from the mean. Okay, so let's see if this point, this is the negative, then you still take one step again to the positive. This will give us another standard deviation. Now, if you move again, you can get 2. This is 2 sigma. Move again here. This is 2 sigma. This is negative, while this side is positive. If I continue to move again, I can have 3 sigma. If I move again, I can have 3 sigma also to the positive. Now, we can have your negative infinity because this is the extreme in the negative, while here is the extreme to the positive infinity, while here is negative infinity. Now, another thing, another standard you need to know about this normal distribution is that the area, the total area covered by this curve is 100%. But for the first deviation, that is from the mean male to this first deviation to the positive and to the negative, is equivalent to 68%. 68%. That's very important. And because each part is equal to the other, and since the total is 68%, it means that here we share 34%, while here we also share 34% for the first deviation. All right, this shaded point which I have made. Also, for the second deviation, the total area that will be covered by this place now, which I'm shading till this place, that is the second deviation, is equivalent to 95.5%. Right, so the total is 95.9%. But you've seen that the first part here has taken 68%. So if I want to know the leftover, I will just say 95.5%, which the total will take, minus 68%, which has already been taken. This will give me 5 cannot minus 8. I borrow 1, put here is 15. 15 minus 8 is just 7. So this is left with 8. 8 minus 6 is 2. So it means here and here we now be sharing 27.5%. And this 27.5% will be shared equally because all these things are normal, they are equal to each other. So if I divide 27.5 by 2, I'll be getting around 13.75. So which means here is 13.75%, while here is also 13.75%. Now, if I journey again, going to the third deviation, now this time around, I've left the second deviation to the third deviation. You will see that I'll cover the total area like this, okay, which is more than the second deviation. Now, from calculations, it is seen that the from calculation, it is seen that the total area covered from the third deviation is equivalent to 99.7%. Okay, and since the first two deviation covered 95.5%. So I've got to remove 95.5% from 99.7% to know the leftover. So I will say minus 95.5%. This will give me 2. This will give me 4. So it is 4.2%. Now, which means here and here we share 4.2%. If I divide 4.2 by 2, I will get 2.1%. So here is also 2.1%. And if I want to know the leftover at this point and this point now, you know that the total area covered by the curve is 100%, and we've taken 99.7%. So I will just say 100% minus 99.7%. When I do that, I'll be getting around 0.3%. Alright? Now this 0.3% will be shared equally between these 2 points. That will give us 0.15%. Here can also be 0.15%. That is exactly what we are going to have there. And this curve is very important. These values there is also very important because it is used in the calculation involved in this normal distribution. So I will clean the board. We shall take question and utilize this thing we've done in solving that question. Okay, so the first question we have here says that a random variable x is normally distributed with mean of 65 and standard deviation of 5. Find A, the probability of the random variable x lying between 60 and 70, that's the standard deviation, x 55 to 75, and x 50 to 80. Before you can solve this, you have to first of all draw this curve. I gave a little sketch of the curve here, but for clarity and understanding, let me still draw again so that you get to solve the question. Where this is the mean, male, and from the question we are told that our mean is 65. So you write 65, mean is at the center. Then again, we were told that it has a standard deviation of 5. Now remember how I told you in sketching the curve. Standard deviation of 5 means that the first standard deviation, that is the first deviation to the left, will be minus 5. And if I remove 5 from 65, I will get a 60. If I add 5 to 65, I will get 70. Remember, it is a standard deviation that you are minusing to the negative and adding to the positive. If I move a second one again, 65, since the standard deviation is 5, 60 will reduce to 55, while 70 will increase to 75. If I move again, let's say the third one, 55 will reduce to 50, while 75 will increase to 80. Now remember, from the first table I drew before this question, I told you how I got the values of all these points here. Here is always 0.15, here is 2.1, here is 13.75, here is 34, here is 34, here is 13.75, here is 2.1, and here is 0.15. Once you know this, you can answer any question that is asked. So the first question here says the probability within this region 60 less than or equal to x less than or equal to 70. Now this is just talking about the probability between 60 and 70, and look at 60 here, this point, and look at 70 at this particular point. So you've got to sum 34 plus 34 because the range 60 to 70 lies just 34 and 34. So it will give us, remember, there are all these things are percentages, percent of the total area, which is 100%. So it will give us 34% plus 34%, which totals to 68%. And 68% means 68 all over 100, which is just 0.68. That's the probability, 0.68. For the second one, we are told to get the probability of 55 less than x less than 75. That is from 55 to 75. That is, we should add from here to here. That's the implication. So it's gonna be 13.75 plus 34 plus 34 plus 13.75. When we add this together, this should be giving us around 95.5. 95.5. That is what it will give us percent. And of course, when you divide this by 100, because percentage means over 100, if I divide 95.5 by 100, I'll be getting 0.955. That's the probability. Then finally, we are told the probability between 50 and 80. Look at 50 here and look at 80 here. So we have to add 2.1 plus this plus this plus this plus this plus this. So we'll have 2.1 plus 13.75 plus 34 plus 34 again plus 13.75, then plus 2.1. When we add this is the same thing as 95.5 plus 4.2, and it will give us 99.7%. Remember, it is percentage. If you want to find the actual probability, you divide 99.7 by 100, because percentage means over 100. This will give us actually 0.997. Okay, so that is just the solution to this particular question here. So let's take one more question for proper mastery. All right, so the last question for this class says that the test scores of a maths class with 600 students are distributed normally with a mean of 75 and a standard deviation of 7. What percentage of the class has a test score between 68 and 82? How many students has a test score between 61 and 89? What is the probability that a student choosing at random has a test score between 54 and 75%? Now, before you answer any question here, you must draw the normal distribution curve. Okay. If you know the curve too well, you will see that this is the mean. The mean, we are told that the mean is 75%, so you write 75 here. Now, the first deviation will be here, and since the standard deviation is 7, it means that what will be here will be 75 minus 7, which is around 68. To the negative, to the positive, you add 7. This will give us 82, because when I add 7 to 75, I will get 82. The second deviation will be minusing 7 again. This will be 61. To the positive, I'll add 7. It will be 89. A third deviation again, when I should be 54, when I remove 7. If I add 7 again, I will get 96. Okay. Now, this is the mean. I remember from the beginning of this video that here is always 34%. Here is 34%. Here is 13.75. Here is 13.75. Here is 2.1. Here is 2.1. Here is 0.13. While here is 0.15. 0.15. 0.15. Okay, now from this curve, now we can now answer any question coming up. The first question says, what percentage of the class has a test between 68 and 82? 68 and 82 is from here to here. Look at 82 here, which is just 34 plus 34. So it's just 34 plus 34, which is 68%. Answer. It says, what percent of the class has a test score between 68 and 82? You just add, you get 68%. That's the required percentage. Okay, the second one says, how many students has a test score between 61 and 89? First of all, let us get test scores between 61 and 89. 61 and 89. Look at 61 here and look at 89 here. So it will be, you add up 13.75 plus 34 plus 34 plus 13.75. When you add up, this should be giving us 95.5. 95.5%. Okay. Now, and how many students do we have there? Because this question is different from the first one. The first one says what percentage of the class, which we got as 68% directly. This time around, they say how many students has the test score between 61 and 89. So 95.5% of the student has it. And how many students are we talking about? 600 students. So it will now be 95.5 over 100 times 600 students over 1. 0 cancel 0. So we now have 95.5 times 6. So 95.5 times 6 will give us exactly 573 students. Okay, so it will give us 573 students. As simple as that. So let's take the third one. So the C part of the question says, what is the probability that a student choosing at random has a test score between 54 and 75? 54 and 75. 54, 75. That is from here to here. So it will just be 2.1 plus 13.75 plus 34, then plus um, 34 only, because they said 54 to 75. So 54 have 2.1, 13.75, and 34. We shouldn't exceed here. Okay, so I wouldn't add again. So if I add up here, I will have, let's say 34, 13.75, then 2.1. Let's add. This is 5, 7 plus 1 is 8. This is 7, this is 9. So we have 49.85%. All right, so 49.85%. Now, this percent means dividing by 100, 49.85 all over 100. And when I divide this by 100, I will get around 0.4985. This is just the required probability. So you've seen that this normal distribution is not a difficult nut to crack, right? So I encourage you to subscribe to this my channel so that whenever I upload new videos pertaining to this probability distribution, you will be the first to enjoy. Thank you.